This is Sergey Khokhlov.
Hello.
Good morning. Good morning, Sergey.
Good morning.
Sergey is director. Yeah, sure. The start the screen. And meanwhile, I will introduce you. You are Sergey is the director of the LLC, the Laboratory of Network Technology in Moscow, and he is also a member of the Underwater Archaeological Society of Russia. So he will give us a talk about the use of cheap surface and submarine automated vessel for research and promote accessible underwater cultural heritage. Let's wait for your screen. Okay, perfect. You can start, Sergey.
Okay. Hello, my name is Sergey Khokhlov. I represent a group of authors from Underwater Archaeological Society from Russia, Moscow. My report is about use of cheap surface and submarine automated vessels for research and promote accessible underwater cultural heritage sites. Remote methods of underwater archaeology are used more and more often. Unmanned surface vehicle, very practical device that allow explore large water areas using different hydrographical and geophysical equipment, like side scan sonar, magnetometer, acoustic profiler. However, high cost of the vessels are not allowed to use it in a small budget research projects. In the last 10 years, there is a progress in development of open source robotic systems. Some systems are comparable to commercial professional solutions, but those solutions are not understandable to users who are not in developing of robotic systems, especially for scientists, archaeologists, ecologists, hydrographers. We decide to develop a cheap and simple solution based on open source and interchangeable models. Unit of the system is a carrier vessel, surface or underwater. It's carrying geophysical equipment. Those units can be united in a network, a fleet of different devices for performing common tasks. In the pictures are concepts of those units. First task to build a fleet is decreasing the price for one unit. Modular system building on open source solution and 3D printed parts much cheaper than existing commercial solution. Using interchangeable components, it can be assembled the necessary vessel for solving specific tasks. It can be unmanned surface vehicle, underwater remote operated vehicle, autonomous underwater vehicle, or it can also be monitoring online video systems for accessible underwater cultural heritage sites. This will allow use those technologies in small budget projects. A core of the system is interchangeable computer control model. Based on it, it is possible to assemble different units underwater or surface. This model was successfully tested underwater for pressure 250 meters. Some pluses of this approach: in the first on site, you can assemble those vessels that are needed at that moment. It is reduce the volume and the weight of equipment during transportation, and the interchangeable components increase the overall level of the system reliability. Using 3D printed parts provide flexibility for specific tasks. At right side of the picture, It is a full cycle of producing an underwater box for camera, from 3D printing to testing. Standard IP camera models can be installed to this box. Those models quite often appear on the market for more and more high resolution. And it is easy to change it in box, getting modern, up-to-date underwater device. Other difficult we see is the restriction of transferring batteries by airplane. So we decide to make battery with the changing lithium-ion batteries elements. It is possible to send elements via ground post or keep this battery set at the working place. Battery models and camera box also tested till 250 meters underwater, but we think it will keep more high pressure. Deeper tests will ahead. On the lakes and rivers, standard catamaran vessel work well, but for sea and big open water areas, big difficulties makes waves. That's why we decided to build small waterplane area twin hull as a one unit of the system. This type of ship used for delivery of pilots in a stormy condition. Small waterplane area allows quite effective resist surface vibration. It's very important for many types of hydrographic and geophysical sensor, for example, side scan sonar. Of course, small vessel 2 meters length can't resist high waves, but it can work in a slightly windy weather at sea. Moreover, this constructor system can be scaled to more longer vessel that can resist higher waves. This is our prototype of USV. All electronics of the vessel installed in an interchangeable computer control module. It's a small cylinder on the nose of the vessel on the left photo. And big box, black box, waterproofed, is using for hydrographical and geophysical third-party equipment. And for transportation of this vessel, it can be packed to one airplane luggage place. It's very important based on our expedition experience. This is tests of our prototype USV in our spring conditions. This is USV prototype following the road by autopilot. Last summer, we successfully tested USV prototype in researching for ancient port area of preserved Tauric Chorsones. It's accessible underwater cultural heritage site. Using USV following the road, side scan sonar mosaic was built. Due to the straight and parallel tracks, it is much better than previous performed scanning of this place from non-automated vessels. Also, during research, together with the underwater department of Preserve, ancient grid-flooded buildings were found, and 3D photogrammetry models of them were created. This is a 3D models, and in the middle, the photo of underwater conditions. Visibility was just about 1 meter. This is our experience of mapping and creating 3D model of the bottom using underwater ROV. Our ROV was equipped with 2 cameras and follow the road by autopilot using complex IMU sensor, electronic compass. On the left small picture, blue squares are placed of underwater photo shoots tracing the way of ROV. The area of map is 2,000 square meters with resolution 200 pixels per 1 meter. Now we are going to assemble from our models special underwater drone for photogrammetry with 2 stereo cameras and distributed powerful lights for dark conditions. On the right picture. This is animation of this 3D model of the bottom. Oh, wait a minute. The development of a project, we see various vessels for different researchers in river and sea conditions. And one other application of this system can be monitoring online video systems for accessible underwater cultural heritage sites. For promoting sites, camera 360 degrees models can share video from site direct to museum or website. And this monitoring online video system also can be used as a secure underwater system, as a motion detecting for accessible underwater cultural heritage sites. That's all. Thank you. If you're interested in this project, this is our web address.
Thanks a lot, Sergey. Very interesting. Your topics are really in line with mine, so I was really interested in your presentation. So now let's move to the next presentation.